Okay, welcome back. So let's take a look at the last part of the system development. You have looked at the different options, you have built your business case, you have identified alternatives, you valued them, you have selected the one you want to go for. So it's time to start implementing that decision, which brings us to the application. And the application stage actually comes in itself in a couple of key aspects, key stages. So the first one is the systems planning and selection, followed by analysis of the system, designing it, implementing it. And actually that goes around. So we call that the software development lifecycle, SDLC. Why is that cycle so important? Because if you talk about the first stage, about system selection and planning, you have to make some choices because you don't have time, you don't have the resources to do everything. So your project needs to be limited in time, in scope, and so on. The next stage is that you will start analyzing, building the case that we've talked about earlier, and you can different ways to select that case. And then it's important to start looking at the business case. So in that very first stage, the system planning is a lot of choices you already made about the business case, about which approach to use, what you're going to select, and so on. So the second part, when we talk about the system analysis, is a key part. So now the question becomes, you're going into more detail. You've decided your project, you've decided the scope roughly, you decided the investment you're going to make, and now it's time to start designing it. And the first step towards designing it is collecting the requirements. So you can do requirements, means you're going to find out what is it that the system needs to do, how should the system function, what should it look like. And there's different ways of gathering these requirements, and requirements engineering is a whole field of study in itself. So we're going to briefly touch about it here. But you can collect that information from interviews, by talking to people. You can conduct surveys. You can observe how people are using the current software, for example. But you could also look at documents, business process manuals. You can look at reports that have been produced, previous projects that have been conducted. But those two, interviews, questionnaires, document analysis, that's very passively obtaining information. Another way of doing it would be to involve your users in the application design, and we're going to talk a little bit more about that at the end of the lecture. So in short, the joint application design means you're actively involving the user and not just looking at documentation and passively observing them and using secondary data. When you talk about analyzing the system, we often talk about building models. Before you even start writing code, you start mapping out what the situation is or what you want it to be. So you can, one way, there are several models you can use. You can use models for the data. So it's shown here, it's a data model diagram, or we call it an entity relationship diagram. That is used, for example, to show what data is being stored in the system. And this is important to design databases. Another way you could look at modeling would be to model or describe or design how the data is flowing through the application. So who changes what, how that data is being processed. But there's a lot of different ways that you can model things. So now we talked about modeling the data, but you can also model how the users will interact with the system, what we call use cases, system interaction diagrams. You can design workflows. You can even design what the interface would look like in a mock-up. So all these requirements, all these models, they are not part of coding. They're not writing the software, but they are vital for programmers to understand what an application should do, what it would need to look like to the user, what it would need to look like for the, what is needed in terms of data storage and databases. So even if you're not a software developer yourself, though, being part of that design process is key because it brings people on the same page. Remember the diagram I showed previously about the cartoon where people looked at the same thing but imagined different things. That is exactly why in this stage you need to use these graphs, these diagrams, to get on the same page about what it is that the system would look like, what it is that the system will do, but also what the system won't do and what you're expecting the users to do. So designing these elements is a key part of it. So that system, once you've designed it, you go into the system design. So once you've designed these flows, you've analyzed what it is that the system needs to do, you start putting it into programs, you start putting it into databases and interfaces. And finally, once you have all those models ready, the coding starts, the programming, the testing, and you start converting those diagrams into software. And probably you go around in that. So I won't go too much into this because software engineering, requirements engineering is a whole field in itself, and I'm looking more at it from the management point of view. It is important to know that you're going around in this circle, and as a project manager or somebody who has a management responsibility in this process, you constantly need to monitor a few things, what we call the project management triangle. Essentially, this one means that your systems development, you need to balance your time, your resources or costs, and the scope of your project, because it will affect the quality of your system. So let's say that you have you usually say pick 2 and then the third one will run off. If you want something cheap and you want it fast, it's going to be poor quality, or it's going to be very limited in the scope. If you want something that has a lot of functions and you have limited time, it's going to cost you a lot of resources, or the quality is going to be poor. So I often use this when I'm involved in projects to tell people who are saying, well, we need it fast, we need it good, we need it on time, and it needs to do this. So it's not possible. You can pick 2, and then the third one, the project will decide. So thinking about these interactions will help you in the project management and be clear to people, to your managers, what you should do. If you don't do that, you get what we call feature creep. Because as the project goes on, people will start thinking about, well, wait a minute, this is also interesting. This is a requirement we should also add. And the system, new things will get added, new buttons will be added, and things will become, people will start thinking about new functions that they want to add, get rediscussions, and it will not be finished. And you will end up with a lot of loose buttons, which is one, referring to the introduction, one of the key issues in government-run IT projects. On the other hand, it is, as I mentioned, important to keep the users involved in that process, because eventually the users are the key adopters and they determine the success of your program. After all, if they don't want to use it or they're reluctant to use it, it will cost you a lot of time and money, and eventually, it will cost you more money. And probably in your business case, often information systems are meant to increase efficiency. So if the end users in the end are not helped with the system, you probably miss your return on investment. So the users, they know what is needed, but they don't always know what is possible in terms of software engineering. And I like this diagram that looks at, from a user's point to programmers, they don't understand what they're doing. It's an alien to them who's just doing things on the computer. So on the one hand, you have the users who have a lot of opinions. They know what they want, or they can articulate the needs, or you can guide that process. They are successful, but they don't always know what is possible or what the limitations are. So on the other hand, you have system analysts, developers, and programmers. They have to make choices, and they know what is possible or what the limitations are, but they don't always know the business side. And often the programmers will see the users as, cavemen or women who don't understand how computers work, and they don't understand the limitations. So a key thing here is that this bridge needs to be formed between system users understanding their requirements, understanding their needs, translating that into what is possible, what is feasible, and what makes sense, considering, again, this project triangle in time, resources, scope, and quality in the middle. If you want to see, one of the best sketches I've seen on the internet is called The Expert, and it's a sketch comedy, and it talks about project management and IT development, about drawing 7 red lines. I won't go into here, but it's about 7 minutes long. If you have a couple of minutes, watch it. It explains actually all the things I have talked about in project management. It makes it very and painfully clear what some of the challenges are in IT project management. So let's say that you've successfully went through this cycle, you've managed your project. Now it is time to start implementing it in the business. You've reached that final stage, the software is done, it's ready to be what we call rolled out. Now there's several options you have. One way that you could do that would be to keep your old system going and use your new system at the same time, and move users, and at some point you're going to cut the old system, but for the time being you would use both systems. Means people are going to do data entry in both systems. One other way you could do it would be a direct cut. So one moment at midnight you're going to shut down the old system, and from 1 minute past midnight you're going to use the new system. So you transition your whole company in one go. The alternative would be that you, for example, would do a staggered. So some people will be in the old system, some people will be in the new system. That will be like you could do per department or several users at a time, you would transition them. And finally, you could do a pilot, for example, one department or a single location before you do the direct transition. So it is a bit of a combination between the parallel system and the direct system. And the last one is something that's often used. Now, what are the advantages of doing it parallel? Well, in parallel, in option A, you would have the option, you will always have a backup. You could, if it doesn't work out, you could switch back to the old system. But of course, the downside is that you'll be doing double the work. You need to keep both systems running and keep them in sync, and all the activities in the system has to be done twice. The direct option, of course, eliminates that because you're only using one system at a time, but it does introduce a risk, as you would, if the new system doesn't work out, you can't go back to the old system. Also, there'll probably be a productivity dip here as well, because as you start using the new system, for all your users, the system will be new and they have to get used to it. So in a phased approach, it's somewhere in between. You still need to have two systems running at the same time, but probably you could manage that some users are using the new system, some users are using the old system. So the issue here would be the load for the IT department to keep the systems in sync. Because if data is entered into the old system, it somehow needs to also be updated in the new system. Otherwise, the people who are using the new system won't see the changes that people who are using the old system are made. So you need to start building an integration between the two. In the pilot, it's actually something that could be a bit easier, where you, for example, think about the university, where a couple of classes that don't have much relationship with other activities are starting to use a new system. So last year we transferred from Blackboard to Canvas, and a few courses were using Canvas, the rest was still on Blackboard, and later last year we all transitioned to Canvas. So that way you use a few people as a pilot, that a few people have to do double work, not all of them, or you use something that doesn't have a relationship with other data in the system. The advantage here is that you could use those people who've been a part of the pilot as ambassadors, or people who could help users that are now transitioning to the new system. The downside here is that you will still have this big cut where everybody's going across, and it will still be a productivity dip, and you have to be ready to support the users there. Finally, regardless of which system you implement, you probably need to integrate and have it work with other systems. So regardless of which way you choose to implement things, your system probably has to integrate with others. I showed you this diagram in the previous lecture on information security, which means that nowadays companies don't run a single piece of software, or software doesn't run in isolation. Software and systems, they are connected with each other. They talk to each other through APIs, through message buses and other kinds of interactions, and they exchange data, or they connect to the same database. That means that you have to think about, if I'm going to implement something, how does that affect that whole ecosystem? Not only the system and the users, but how does it affect other systems? How do we keep things up to date? Which connections should we cut? Which new connections should be made? And this is really what would be in the field, in the realm of enterprise architecture. And that's a whole study in itself. Anyway, so when we talk about implementing systems, remember that we're not only talking about users. It could be that the users are fairly easy transferred, but databases, connections from one to an old system nowadays can be extremely difficult to move around. So keep that in mind when you say implementing systems. Make sure you check, what the old system was connected to before you put something new in, and which ties you're severing and which ones you're connecting new. So finally, the final step, if we go back to this rational decision-making process, we recognized that we needed to make a decision. We've looked at what options we have. We've evaluated the options. We've decided to implement the system. Now the next step is to evaluate the system. And it actually goes back to, did we make that decision, and did we accomplish the objectives we set out in the beginning? Are we delivering on this business case that we mentioned? And if so, if not, why not? And how do we fix that? So evaluating is a key component in information systems development, because it allows you to correct any mistakes, but more importantly, it allows you to learn and improve things for next time. And often we're all too happy that a new system is in place and we're celebrating it. We're doing some bug fixes, but we have not seen what we've learned from this process to do it better next time. Not only for the system, but also what we learned as an organization. What worked well? How were the users involved? What should we do better next time to shorten the development time, to reduce the cost, and so on. When you implement a new system, evaluation is key. Let's start with looking at, evaluating the system itself. Why do we evaluate? Because often we design systems and we think of systems from a certain perspective. We think the user, we assume, or we think the user is going to behave a certain way. They're going to click there. Oh, this is going to be easy for them. Oh, this will make their life easier. So we often make a lot of assumptions about the user. They don't always or rarely turn out to be true. This is a great picture that is often used when we talk about human-centered design. So we design something in mind that we think is great, but actually the user would have a different experience. So we think that it's a beautiful design barrier with easy to go around, well designed, but actually for the user it's easy to cut across the grass, even though, from an interface design that would not be the preferred option. So keep in mind that you constantly have to check if people are using the system in the way that you intended and if they're delivering on that benefit. That's why if we go back to this cycle of developing systems, you have planning, selection, you're analyzing the requirements, you're designing your flows, you're implementing it in code. There's actually a circle going around it, which is maintenance. So the system is in place, but rarely that's the end goal. As remember when I talked about the golden handcuffs, you can have a once-off implementation. There goes talk about implementation, there goes my painting on the wall. So you can have this once-off implementation, but often you start to need making changes because people will have additional requests, the requirements are not clear, a new update comes along, so you need to make changes. So one would be actually a cycle outside this, checking what needs to be changed. First step is to get the maintenance requests. The second would be, okay, so if we want to implement it, what does that mean for our system? What changes do have to be made? So you transform a request into a change. Then you start designing them. If we make this change, what should it look like in the interface? What changes should we make in our business process? What enterprise, what needs to be changed in terms of data in the backend? Again, you implement them and you move on to the next maintenance request. So you actually have these two cycles. One is the maintenance and the management who decide, again, a project manager who manages the scope. and the internal one would be development cycle. And these are happening at the same time. Now, what I showed you here is what we would call, again, going back to what I said in the beginning, that this is the way ideally it would work. You start with recognize you need to make a business case, you identify your alternatives, you choose a way to implement your information system, you do it, you apply it, and then you evaluate and make changes as is needed. However, that rational decision-making process, as you might know already have considered, is not how it happens in reality. Why not? Because we don't always have the information that we need. We make assumptions. We think that we know the requirements, but in fact we don't. We are not objective. We have our own opinions. There's not a lot. We have to deal with uncertainty. Things will change. The environment will change. The business will change. The economy will change. When we make a choice now, when we start building a system now, by the time it will be ready, the world could look differently. So there is a temporal effect. And as humans, we're not rational. We make decisions because we like something, because of a button, because we believe something, because we have prior experience. So that rational decision-making process is a way to think about it, but it is not the reality. And that's also something you've seen in information systems development and software engineering. A traditional method would be that we use this linear approach almost. We start with requirements, what does it need to do? We design it, we build it, we verify it, and we go into maintenance. We call this the waterfall approach because each step of that development follows the next one. We go from requirements, then we design these requirements into a system, we build it, we put it in place, we verify, evaluate if it works, and we start doing the maintenance on the system. That's what we call the waterfall model. A slightly different version of that will be called the V model. Again, on the left side here, you will see these steps: analysis, design, implementation, and then the building part. But now we would also start verifying it. So we verify the design, we verify the integration, we verify the systems, and we verify if we've solved the requirements. So that's what we call the V model. But again, it is a very linear, structured approach. So what other approaches are there if we don't use this linear or this sequential system? It is prototyping, trial and error. There's different ways about it. You can call it different ways: rapid application development, RAD, or extreme programming. So we often use that when we don't know what the requirements will be. So we start with a prototype and say, hey, is this what you meant? And then we will make changes. So we actually build and do the requirements at the same time. You build something, use that to solicit the requirements, use that to improve your prototype, and you will go through several cycles, and with each cycle you learn and you uncover more of the requirements. Going back to what we said in the beginning about involving the user and helping them understand what is possible, what is not possible, and at the same time learning what it is the user wants, this is an excellent way of doing it. You involve the user in the process, and at regular intervals you give them the possibility to give feedback. The best way, this is often referred to as agile development. So you can see it as different stages where you analyze, you plan it, then you go into this cycle, a few rounds of design and building, and then you deploy it, which means you use that part of the code or that part of the system is done, and you move on to the next one, and again a few cycles and so on. This is called agile development because you don't need to specify the project at the beginning. You can uncover the requirements as you go on. What is the downside of this? That if you talk about Waterfall, it is a very structured way. It requires you to think about the whole system before you start building it, which is excellent for systems that need to be very robust, that if you need to have a fixed project scope, you need to have things done and you know what you want. So Waterfall approach, the linear approach, is often used for projects with a very well-defined scope, where we need a very deliberate, well thought through design. For example, high reliability systems. Agile development, the upside is you don't need to know the requirements. You can uncover and you can adapt to the situation as you will as the project goes on. The downside, as you may guess, is that when you do agile development, you don't know what the end goal is, and the risk is that the project will continue and start creeping. So with every cycle, there might be something new you discover. Even more, as that project lasts longer, circumstances will changed, and so will have the requirements, and so you need to revise the prototype completely. So with the risk of agile development is that there is no end state, and you don't know when the project will be done. Some companies have embraced that and will say, well, this is, we're going to keep developing, we're going to keep changing, but you have limited resources, a limited project budget, limited time. The risk of agile is that you will end up with a prototype and it won't be finished because you're still in this cycle of finding out the requirements. Therefore, it's important to make sure that in agile you either define these end states, or that every delivery, it's not only a prototype, but you also work to really systems that can be deployed as stages. So that brings me to this last slide about information management when it comes to information systems development and acquisition. I think throughout this lecture you've seen that I've talked about a lot of different aspects about systems development. And these are aspects that if you are an information manager and you're responsible for a project, you don't necessarily have to be a coder, but you do need to understand what is possible, what is not. So you need to have some IT knowledge, but you also probably need to train users. You need to teach them. You need to manage the project guarding the scope. You need to think about this design of all the systems interacting with each other. So an architect, you need to solve problems. You need to analyze what is needed. So an information manager when it comes to project management is actually a lot more than just a system analyst or an IT developer. It is somebody who does have all these different hats on, all these different roles, and is managing to navigate that field, but also manage that business case, that choices making, the alternatives, and help people, help management, help the users, help the IT department in making choices that are aligned between them. So I hopefully that this presentation has mainly given you an insight in all these different aspects that are involved in information systems development, and hopefully you'll find some inspiration in that for yourself. Thank you so much for watching.